Look at this shifting, unstable cloud of data. This represents the core vulnerability of standard generative models in an enterprise environment. They are probabilistic pattern matchers, guessing the next word based on statistical likelihood rather than querying a factual database. That statistical guesswork creates a trust gap for corporate IT. When a model relies on probability, it is prone to hallucination, inventing facts when it lacks data. Combine that with the risk of exfiltrating sensitive company information to external servers, and standard models become impossible to deploy on proprietary ledgers. To solve this, the architecture must shift entirely. We have to move away from stochastic word prediction and build systems grounded in rigid deterministic reasoning. Stochastic means randomly determined, having a random probability distribution that cannot be predicted precisely. Treecapital Technologies engineered ANVEN 1.0 as a sovereign intelligence layer for secure, enterprise-grade cognitive processing. The core operational difference lies in control. ANVEN strips away the creative variance that causes hallucinations, and it executes entirely within an organization's secure network perimeter. This architecture relies on three distinct pillars. First, mathematical constraints that tie responses directly to ground truth. Second, relational data orchestration to synthesize complex variables. And third, absolute physical network isolation. Conversational novelties and clever writing aids are insufficient for actual business operations. A sovereign, deterministic architecture is the absolute prerequisite for extracting actionable intelligence from corporate data. This schematic shows the ANVEN architecture, specifically focusing on a primary generation node. Notice how the parameter slider locks firmly onto a temperature of 0.0. By forcing this parameter to 0, the system eliminates creative variance and ensures strict, repeatable, deterministic outputs. To prevent hallucinations, the model abandons reliance on its pre-trained weights for factual recall. Instead, it uses a native retrieval-augmented generation, or RAG, architecture. RAG is a framework that forces the AI to search a specific external database before generating an answer. This localized ecosystem acts as a restrictive reasoning engine. The model's responses are strictly bounded by the retrieved internal knowledge base, blocking it from inventing outside information. Before deploying this kind of deterministic system into production, engineers must quantify its accuracy using systematic evaluation frameworks. These evaluations function like software unit tests. They continuously measure the model's generated outputs against a curated set of ground truth telemetry, ensuring the system retrieves and applies the correct data every time. The validation tests rely on rigorous metrics. They use exact match Boolean checks for objective classification tasks and semantic similarity calculations to measure how closely the meaning of the AI's response aligns with the reference data. If the required information is missing or incomplete within the database, the system does not attempt to guess. It enforces strict abstention logic, actively stating that there is insufficient data to provide an answer. This localized retrieval enables the system to optimize latency and reduce operational costs by up to 60%. By isolating the exact context needed before generation, the model processes dense proprietary data with significantly less overhead. Enterprise precision doesn't come from simply scaling up parameter counts. It's the direct result of mathematical temperature constraints combined with highly validated retrieval pipelines. Flat document retrieval is only the first step. The difficulty lies in analyzing fragmented, relational data stored across disparate enterprise SQL systems. SQL, or Structured Query Language, is the standard programming language used to manage and manipulate relational databases. This diagram illustrates the orchestration sector of the system. At the center is a LangChain agent node connected to three distinct SQL tables: billing, context, and telemetry. LangChain is an orchestration framework designed to connect language models with external tools and databases to build complex applications. The agent applies chain-of-thought reasoning to decompose a single natural language input into multiple logical subtasks. Chain of thought is a prompting technique that forces the model to generate intermediate reasoning steps before arriving at a final conclusion. In the autonomous execution phase, the agent formulates and fires concurrent, syntax-perfect SQL queries to these separate databases without any human intervention. The system executes the extraction process by retrieving isolated rows from the billing ledgers, pulling user context files, and gathering technical telemetry simultaneously. Next comes the synthesis process. Those disparate, raw data streams are combined back together to formulate a unified, highly accurate answer. This workflow entirely bypasses simple semantic search. Instead, it creates dynamic, multivariable analytical conclusions on the fly, calculating relationships across different data structures. The orchestration relies heavily on sequential chains. The output tensor of one database query serves directly as the input parameter for the next logical chain, allowing the agent to dig deeper based on its initial findings. This precise sequential routing prevents context dilution. By holding only the necessary variables at each step, the system preserves strict accuracy across complex, multi-turn data extractions. Compared to dumping thousands of rows into a single monolithic prompt, this multi-agent orchestration enables a 90% reduction in inference costs and significantly lower compute latency. True enterprise intelligence depends on an agentic reasoning engine that autonomously queries and synthesizes relational architecture. This schematic outlines the absolute prerequisite for deploying reasoning engines on proprietary ledgers: infrastructure-level data sovereignty. That boundary designates the Virtual Private Cloud, or VPC. A VPC is an isolated private network hosted within a public cloud, allowing organizations to securely launch resources. Standard multi-tenant cloud APIs process data on shared external servers. Those external network calls carry inherent vulnerabilities and frequently result in compliance failures for highly regulated industries. ANVEN operates entirely on-premise or within air-gapped VPCs deployed across major providers like AWS, Azure, or GCP. Air-gapped means the system is physically and logically isolated from unsecured networks, including the public AirNet. This strict physical and network-level isolation mathematically guarantees zero exfiltration of proprietary telemetry. The data physically cannot leave the building. This diagram demonstrates how the system handles internal data security using multi-user role-based access control, or RBAC. RBAC is a security paradigm that restricts network access based on the role and privileges of the individual user within the organization. The model dynamically restricts its own context window. It lets retrieval parameters based purely on the authenticated user's permissions, ensuring employees only query data they are explicitly allowed to see. All internal service-to-service communication is encrypted using mutual TLS, or MTLS. MTLS is a security protocol that requires both the client and the server to authenticate each other using cryptographic certificates before sharing data, preventing any lateral interception within the network. The architecture continuously generates immutable audit trails for every query processed and every tool invoked by the agent. Immutable means the logs are cryptographically locked and cannot be altered or deleted. These unalterable logs satisfy the strict regulatory compliance mandates required by enterprise IT leaders, including standards like HIPAA for healthcare and PCI DSS for finance. For mission-critical deployments, the system utilizes an active-active multi-region deployment strategy. Active-active refers to a network architecture where multiple identical data centers run simultaneously to ensure high availability and rapid disaster recovery. True AI security cannot be achieved through easily bypassed software prompts. It requires absolute physical network isolation governed by strict IAM infrastructure protocols. The final stage of the agentic workflow translates the synthesized internal reasoning into actionable, structured execution. This graphic shows the universal export engine. The engine catches the final output tensor and rapidly structures it into a rigid, neatly formatted JSON schema grid. Output parsers constrain the model to deliver its findings strictly within formats like JSON or YAML. By doing so, it strips out all conversational filler and returns only the raw payload. The system then uses the Model Context Protocol, or MCP, to interact directly with external enterprise storage without breaking security protocols. MCP is a standardized open-source interface that allows AI agents to securely connect with local and remote data sources. These tools allow the model to autonomously compile polished PDFs, update Excel ledgers, or execute distinct administrative actions. The complete architectural journey of a query begins with deterministic RAG retrieval, moves through LangChain orchestration, operates entirely within air-gapped security, and finishes with structured export. This infrastructure bridges the gap between raw, highly secure proprietary data and production-ready enterprise action. Ultimately, ANVEN serves as a complete sovereign infrastructure layer, establishing absolute, verifiable architectural stability for your corporate intelligence.